This is section 5 of chapter 2 of geometry. Our topic today is reasoning and algebra and geometry. Our objective is to connect reasoning and algebra and geometry. So the first thing that we're going to do is we're going to follow this brain teaser. It says write down your age. So if you're 16, you're going to write that down. I'm going to pull out a calculator for this too. And then multiply your age by 10. So 16 times 10. Add 8 to the product, so add 8. Should be at 168 now. Double that answer, so multiply by 2. Then subtract 16, so now we're at 320. And then finally divide the result by 2. And what do you get? You get 160, which is 10 times bigger than what your original age was of 16. And so I think you guys can figure out what's happening there and what do you notice, and explain how this brain teaser works. If you try any other ages, you're going to get the exact same thing again. If you're 17 and you plug that in there, you're going to get 170 for your answer. And so figure out why that works. So pause the video now. Alright, so math is more than just about numbers. It's all about following a logical series of steps. And so algebraic properties of equality that you've known are used in geometry, and they're going to help us solve problems and justify each step we take. Remember that in geometry we accept postulates and properties as true. This does include all the properties you used in algebra. So here are some properties that we used in algebra. We've used the addition property. If A equals B, then A plus C is the same as B plus C. We've used the subtraction property, same thing. If A equals B, then A minus C equals B minus C. The multiplication property, if A equals B, then A times C equals B times C. The division property, if A equals B and C does not equal 0, that's really important, then A divided by C is the same as B divided by C. We've used the reflexive property, something equals itself, so A equals A. We've used the symmetric property, if A equals B, then B equals A. We've used the transitive property, if A equals B and B equals C, then A equals C. And we have used the substitution property, if A equals B, then B can replace any A in any expression. And so we're going to use these properties to just kind of quickly solve this equation, 3x plus 7 equals 16. So if we write that down, we get 3x plus 7 equals 16. Well, we know by the subtraction property, if two things are equal, we subtract the same thing from both sides, it's still equal, so I can subtract 7. As long as I do it to both sides, then I'll have 3x equals 16 minus 7 is 9. So that was the subtraction property. Now I have 3x equals 9, and then I can use our division property. If two things are equal, I can divide them both by the same thing. Divide by 3, divided by 3, and that was the division property. In this result, I had to do a division, and I get x equals 3, and there we have it. And so we use these algebraic properties of equality to justify each step that we took in solving. So another property that we're going to talk about is the distributive property. This is a really important one that helps us with a lot of different stuff. It says that A times the sum of B plus C is the same as A times B plus A times C. It works in subtraction as well. A times the difference of B minus C is the same as A times B minus A times C. And so solving an equation is just using this deductive reasoning. And what we're going to do is we're going to justify each step in our solution with a postulate, property, or a definition. You can use, why the distributive property is so helpful is you can use the distributive property to justify combining like terms. And so, for example, here that helps us justify combining these like terms. Once again, it does it there as well. And down below, you can see it with some numerical examples. It helps us simplify 2x plus x into 3x. All right. So here we have a situation. We've got two angles, and we want to find out this value of x. So First thing I'm going to say is that these two angles form a linear pair, and the way I know that is that they are in a straight line. Remember, if they form a linear pair, their sum is 180 degrees, so I can say 2x plus 30 plus x equals 180, and this is because they are a linear pair. I don't know why it keeps turning into black. We're just going to change the color. Alright, so now I can use another property that says now I can use the distributive property to combine my terms 2x and x, and I get 3x plus 30 equals 180, and that was the distributive property. Okay, and now I can use my subtraction property to subtract 30 from both sides, and I get 3x equals, there we go, 150, and that was by the subtraction property. Now I can use the division property, divide by 3, x equals 50 by the division property of equality. And there you have it. We solved for x. We justified each step as we went, which is exactly what we need to do. So, you are now going to do a similar process here. So, pause the video and take the time to do that here. Alright, so you can kind of see my work here. It's a little bit rusty at first. It says, given ray AB bisects angle RAN. That was our given statement. From that, then I can say that x equals 2x minus 75, given the definition of angle bisector. I can then use the subtraction property of equality, subtract 2x from both sides, and I get negative x equals negative 75. And then I use the multiplication property of equality to get x equals 75. And so what you kind of see is the beginning of a two-column proof, and that's what we're going to be talking about in the next few slides. And so some properties of equality have corresponding properties of congruence, and so we have some congruence properties here. The reflexive property of congruence. Segment AB is congruent to segment AB, angle A is congruent to angle A. Symmetric property of congruence. If segment AB is congruent to segment CD, then segment CD is congruent to segment AB. And then we also have the transitive property. If segment AB is congruent to CD, and segment CD is congruent to segment EF, and segment AB is congruent to segment EF. And so we're going to use these properties of equality and congruence to justify these steps. And so if we look how we went from 2x plus 9 equals 19 to 2x equals 10, what do we use there? Well, it looks like we subtracted 9 from both sides, and so we use our subtraction property of equality to do that step. If we look at this next one, we see that angle O is congruent to angle W, and angle W is congruent to angle L. Well, this is the transitive property of congruence. We use congruence since they have congruent symbols instead of the equal symbol. And here we have measure of angle E is congruent to the measure of angle T. The measure of angle T is congruent to the measure of angle E. This here is our symmetric property of congruence, of equality, sorry. And there we just justified how we went from step to step. So what I'm going to have you do now is scroll down to these problems right here. For A, B, and C, what is the name of the property of equality or congruence that justifies going from the first to the second statement? And then D, what property justifies the statement below? So pause the video here and do those. And so here you can check your answers with mine. For A, it's the reflexive property. Sorry, that should say the symmetric, not the reflexive. Glad I got that one. It's a symmetric property of congruence. B is the distributive property. C is the multiplication property of equality. And D is the D shows the reflexive property of equality. So, what we're going to be talking about next is a proof. And a proof is a convincing argument that uses deductive reasoning. The steps of a proof logically show why a conjecture is true. A two-column proof lists each statement on the left and then a reason or justification on the right. Each step should follow logically from the steps before it. So here's an example. You're given a statement right here. Measure of angle 1 is equal to measure of angle 3. Okay, so we're given that. We need to then prove that the measure of angle AEC is equal to the measure of angle DEB. So the first statement is usually the given, and so we can see that the reason is that it was given. And then in here we have a series of logical steps with reasons for each step that we take, and the last statement is what we want to prove. And so it could take 5 lines, it could take 3, it could take 10, it just depends on the situation. So let's do a proof now. So here's that same problem, and we're going to write a two-column proof of this. So the first thing I'm going to do is I'm just going to set that up. We're going to have our statements, and then we're going to give it some space, and we're going to have our reasons over here. I'm even going to draw a line down there just so that I separate the two. And there we have it. So our first statement that we were given was measure of angle, and I don't have all this math notation in here, but I'm going to try my best, is equals the measure of angle 3. And the reason for this is that it was given. And we a lot of times remember these as we go. This is the first statement, and so we correspond that with our given over here. Okay. So, what's our first statement? And so if we're trying to prove that AEC is equal to DEB, we need to deal with angles 1, 2, and 3. And so, some stuff we can say about angle 2. What can we say about angle 2? Well, we can say that the measure of angle 2, what is that equal to? Well, by the reflexive property, it's equal to itself. So that's what I'm going to say. And I'm going to say by the reflexive property. I'm going to move these over just a little bit so I have more space when I need to give some longer reasonings. Alright. So there we have our steps. 3, what else could we say then? Well, if we look back to some different things we can do, I need to get angle 2 put in with the measure of angle 1 and angle 3 somehow. And so if we look back, take a look at the addition property. It says that if two things are equal, then I can add the same thing to both of them. So why don't we do that? Okay, we're going to say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. I am already running out of space. So maybe I should move. I'm going to pause it right here and just try and fix my formatting a little. And my formatting's a little better. And so remember we said we could add angle 2 to both sides by the addition property. So addition prof. So now we're on to step 4. So remember the whole goal is to get the measure of angle AEC to equal the measure of angle DEB. Well, angle 1 and angle 2, if we look at those two together up in our drawing, angle 1 is here, and angle 2 is right next to it. Would you say that those two combined make that big angle AEC? I would. So why don't we put that into our proof then? So for step 4, we're going to say the measure of angle 1 plus the measure of angle 2 equals the measure of angle AEC. Okay, and through that we can also say in that same step, because if we look at that drawing, we can say some stuff about angle 3 and angle 2. So we have angle 3 here, we have angle 2 here. Together they make that big angle BED. So we're going to put that into our proof as well. The measure of angle 3 plus the measure of angle 2 equals the measure of angle, and they call it DEB in the problem, so that's what I'm going to call it down here. measure of angle DEB. And the reason we can say this, that's going to be our step 4 over here. The reason we can say this is because the angle addition postulate that we talked about earlier. And let me just copy paste this, move it. There we go. So we're almost there now. So now we have that angle 1 and angle 2 together make AEC, angle 3 and angle 2 make DEB. And remember we said in the previous step, the measure of angle 2 plus the measure of angle C equals the measure of angle 3 plus the measure of angle 2. Well, now what if we substitute in? And we can do that. We can do a substitution property. If you look, that's back on page 113 in your textbook. Remember, if A equals B, then B can replace A in any expression. So we can say, well, if the measure of angle 1 and the measure of angle 2 is angle AEC, we can replace that. And the same goes for measure of angle 3 and measure of angle 2 for DEB. So now we can say that the measure of angle AEC equals the measure of angle DEB by the substitution property. And there we have our very first 2-column proof. So let's follow through it. We start off with the given statement they gave us that we knew was true. Our reason was that it was given. And then, well, we already knew a lot of information about angles 1 and 3, and so we just tried to tie in angle 2 in there somewhere. And so we said that, well, the measure of angle 2 is the same as the measure of angle 2 by the reflexive property. And then we use the addition property to say that the measure of angle 2 plus, we can add it to both sides because it's the same as itself. And then we use the angle addition postulate to say that, well, I know that these 2 angles must make up this third angle. And these 2 angles must make up this third angle. And then I saw that I could replace this in for 1 and 2, and this I could replace in for 3 and 2, and so then I use the substitution property to make my final statement. And so that was our 2-column proof. What you're going to do now is you're going to try and write a 2-column proof for this given and prove AC is equal to BD. You may need to flip back and look at some of the other theorems and postulates we've talked to, but pause the video. Alright, you can take a look at my proof. I took my given statement and I said that I wrote that down for my first step. Then I noticed that, okay, well, congruent segments have equal length, so I can say AB equals CD. Then I can use the reflexive property again to say that BC is the same as BC, which then I can use the additive property to add the BC to AB into CD on opposite sides of the equation. And then I can use a segment addition postulate to say that AB plus BC is AC and CD plus BC is BD, which is exactly the segments I needed. So then I use the substitution property to plug those back in. I get AC equals AD, but remember I need to get it into a congruent statement. So I know that segments with equal lengths are congruent, and so I can say my final statement, AC is congruent to AD. So that's the end of section 5 of chapter 2 geometry.